That's our completed pair of tongs, made the traditional way with a jaw forged from larger material and a rein from smaller material forged welded on, so you don't have to do all that big drawing out that most people do under a power hammer these days. Our tongs will start with half-inch blows at the near edge of the anvil. This will be forming the jaw of the tongs. The next step is to form the boss, or the hinge joint of the tongs. For this, we're going to do half-face blows again, this time at the far edge of the anvil. You want to rotate the tongs towards your tong hand, not towards the hammer hand. This is important later, and I'll explain the difference between right-handed tongs and left-handed tongs before we get to the end of the video. But rotate the material towards your tong hand 90 degrees, offset the jaw we just forged, and step that down to about half the thickness of the material. Once we have the boss kind of established, I'm going to rotate 90 degrees again towards my tong hand and establish where the reins will start. As you start to establish these different areas, you'll want to go back and refine them using the exact same procedure. You're just trying to clean everything up and make it all look better. So I've been messing around with this for several heats now, just trying to get it refined. I left a little bit too much material for the boss, and I've been trying to work it back into a round. Doesn't really matter if it's kind of rectangular or oval shape. I just like the look of the round boss better. And I figure if I'm going to take the time to make a pair of tongs, I might as well take the time to make them look the way I want them to look. Next thing we want to do is cut this off and scarf it in preparation for a forge weld. Then I'll go ahead and do the second jaw exactly the same as the first jaw. Flat jaw tongs, wolf jaw tongs, V-bit tongs, rivet tongs, pickup tongs. The jaws are all identical left to right. It's when you flip them over that they fit. So it's easy to think that you need to make mirror images. You're not. You're making two identical pieces. I started that scarf on the wrong side, so I pushed it back over, and this way the jaw can lay flat on the anvil when we go to make our weld. And as I said, we'll do the exact same thing for the other half of the tongs. Got a little carried away there. Try not to cut all the way through on the hardy. That's hard on the hardy and on your hammer. I think I need to interject a little bit of reality here. There are several problems with this approach if you're a new blacksmith. Been doing this for a while. This is the way I think you ought to be making tongs because it's a good skill builder, makes a good pair of tongs, and it's really a pretty efficient way to go if you don't have a power hammer. The first problem, you'll notice I'm holding this part in a pair of tongs. When I forge weld the reins, I'm going to need to bring this out of the fire and set this on the anvil, again, holding it with a pair of tongs. So for this approach, you need to have tongs to make tongs. Now, another way you can do this is draw out the reins from square bar. Taking 3/4 or even 5/8 if you make a light duty pair of tongs is a lot of work to draw out if you're not used to it. Now, after you've been blacksmithing for a while, you're going to develop the hammer control and the hand-eye coordination, and you're going to be able to draw out heavy bar a lot more efficiently. But if you're just getting started and this is one of the first projects you're trying to tackle in your shop, the reality is you're probably not going to get very far trying to draw these out by hand. It's going to frustrate you. It's not going to result in a good finished pair of tongs. And there's a good chance you won't be happy with what you end up with. The other little bit of reality, doing it this way, which doesn't require all that heavy drawing out, so therefore it's physically easier, more efficient of your time and your fuel and your forge, is that you have to be able to forge weld. Again, if you're just starting out, you probably haven't mastered the skill of forge welding, and this probably isn't the project to try your first forge weld on. You should learn to forge weld before you get to this point. Now, I think forge welding is a fundamental. Everybody needs to learn to forge weld if you have a forge that will reach welding temperature. But learn to forge weld first before you try making a pair of tongs this way. So where does that leave us? And I have said this before, I'm going to repeat myself here again today. Your best bet if you're starting out is to buy some pre-made tongs. All of the blacksmithing manufacturers sell tongs. This is a pair of Quick and Dirty Toolworks tongs. This is a pair of off-center tongs from Blacksmith's Depot. The wolf jaw tongs I'm using for this project came from Blacksmith Supply. There are lots of places you can buy ready-made tongs, and using tongs as you work, you'll learn what works, what doesn't work. You'll understand how tongs function, why they're shaped the way they're shaped. And that'll give you a much better chance of success when you start to make your own tongs. Another approach, I'd still probably start buying 1 or 2 pair, but then move to the pre-cut blanks such as Ken's Custom Iron Cells. And this is a good way to start with the majority of the work done for you. You just have to do the forging that makes this into the pair of tongs that you want them to be. Now, buying tongs can be expensive. These run somewhere between $30 and $50 a pair, depending on what you're buying and where you're buying them from. And I understand that can be a problem. The sponsor of today's video, Vevor, sent some tongs for us to look at. This is a 4-piece set, sells for about $80, so that's more like $20 per pair of tongs. And it might not be a bad way to go. Now, if you buy their individual tongs, they are more expensive. They're more like $30 a pair, something like that. So if I were buying from them, I'd probably buy this set. Like I say, they are sponsoring the video, and they did send the tongs out for free. Well, that's better than I thought. I was afraid these would be really light and flimsy. They are somewhat crudely made. You can see machine marks in them where these have been bent under a press, but they seem to work. Looks like there's a pair of bolt jaw or V-bit tongs, as well as an offset pair. It's the same size pair of tongs. Looks like it fits the 3/8 round bar that we've been using here in this little shop so much. Should also fit 3/8 square bar just fine, and may hold some size of flat bar. The offset tongs have the advantage that you can run a long bar through here and still work close to the end. Gives you a little bit better control of your work. And there's a pair of wolf jaw tongs, and I think these would have worked just fine for everything I've been doing with that other pair of wolf jaw tongs. And then there's these things that are kind of a flat jaw, but they've got a bow in them. I'm not sure what you'd use these for. I might reforge them and put a V-bit in there or do something else with them. Now, I would be careful with all of the store-bought tongs. They are frequently made out of an alloy steel. If you get the tongs hot or you reforge them to reshape them, there may be some heat treating issues there. And certainly if it gets hot in use and you just quench it in the quench tank to cool it off so you can get back to work, you can actually break your tongs. And that goes for all of the store-bought tongs. I don't know what material they're making out of, but I have broken tongs in the past after quenching them. The tongs I'm working on today are just mild steel, so if you need to quench them in use because they got hot, it's not going to hurt anything. And I really do recommend making your tongs out of mild steel, unless there's a really good reason for using some other alloy. So these tongs certainly look functional. I think the jaws are a little bit light compared to the reins. The reins are really heavy. These could be about half the weight and probably be just as useful. But if the price is right for your budget, these might not be a bad way to go. Certainly worth checking out. But if you do have more money in your budget, I can certainly recommend checking out one of the U.S. manufacturers. Off-center tongs and quick and dirty tongs are made here in the U.S., as are the blanks from Ken's Custom Iron. A lot of the tongs from the other suppliers are imports, but they're still pretty good tongs, and they are being sold by somebody who supports the blacksmithing community. But anyways, I want to thank Vevor for sponsoring the video, for supporting the channel, and making it possible to bring these videos to you folks out there. Now the next step on the pair of tongs we're working on is to put a scarf on this. When you forge weld, it's really hot. You're going to reduce the material quite quickly, so you need to upset this so you have more mass to start with. This weld area could be the weakest point of the tongs, and you don't want to overly thin this if you can avoid it. Upsetting into the step of the anvil or a V-swedge helps concentrate the energy a little bit and makes the process go a little faster. Now this is sort of a long floppy heat that I have on these pieces, but I want the upset to be a gradual transition from the upset back into the 3/8 bar stock. And that'll make it easier to get a nice transition when we refine the weld. A good clean fire is critical for forge welding, so this is a great time to stop, clean out your fire, get rid of any clinker, bring in new coal and get it all up to heat before you try to make the weld. The coal I have here is really dirty and it forms a lot of clinker. It's really kind of a pain to weld in. Now, clinker is a hard, glassy-like substance. All the impurities from the coal scale from the material you're working on, and any other junk in the fire that melts together. This is often referred to as a drop the tongs weld, because you have to drop the tongs. You brought one piece out, so you can pick up the hammer. I did not get this aligned as well as I would like, but it is stuck, so I'm going to reflux, go back to the fire, and see if I can get all that stuff tucked back in. I'm not actually trying to move the pieces at this point that would shear the weld. I just want to forge what's sticking out of one side back into the mass. Hope that makes sense. If you've never done this kind of welding before, it pays to rehearse getting to the anvil, dropping the tongs, and picking up the hammer several times with cold material before you ever go to the fire. Real light blows down into a black heat help knock the scale off and smooth over the finish. You don't want to be doing any serious forging at a low heat. That's a good way to cause problems. Bring these up to heat slowly so you don't burn your scarves. The flux I'm using is Iron Mountain flux. You can really use whatever your personal preference is. Borax works, but it is more slippery, and that makes it harder to get this weld that you got to bring together on the anvil and keep it in place before it's actually welded. So for that, the Iron Mountain flux seems to be grippier. It's got some iron filings in it, and that really helps. But no flux is magic. It's not going to make a bad weld stick. You still have to have good scarves and a good heat. And for that matter, you can weld without flux. The flux just helps keep the weld area clean. The heat I'm looking for is a bright lemon yellow. I think white hot is going too far, but everybody's eye sees color differently, so you just have to learn the way you perceive the colors in your shop. There's no reason to keep hammering on this once it cools off below welding heat. Wire brush it, flux it, get it back in the fire, and get it hot again. Once the weld is complete, then you can work it down into a lower heat and refine the weld. I've let our two halves of the tongs cool, and this way we can kind of check the fit. Might need to do a little bit of filing or grinding to get things to fit well, and I can lay out for the hole. So the question is, punch the hole or drill the hole? There's advantages either way. If you punch the hole, you're losing less material. You're displacing material into the boss. And if your boss is a little bit on the small side, you might appreciate making it a little bit stronger. Drilling the hole, on the other hand, is more precise, it's more accurate. You'll get a smoother working pair of tongs, and the rivet will probably last longer. I usually like to go with the compromise method. I punch the hole a little undersize, and then I drill it to the final size. So I'm getting a little bit of the benefit of both methods. But before I heat them up again to punch them, I want to go ahead and do a little filing right here at this transition point. That's rarely a real clean forging right there, so it's nice to go in and file that so your tongs fit better in the long run. I'm going to put a little chisel cut in this, and once they're assembled, I will use that to index a piece of square bar, and that way they'll hold round bar or square bar on the diamond a little bit better than just flat jaw tongs would. I use 3/8 round bar for the rivet. General rule of thumb is 1.5 times the diameter of the bar for each rivet head. Now I think a torch is the best way to do this. I just want to show that you don't have to have a torch or a power hammer or a drill press or any of that kind of stuff to be able to make your own tongs the traditional way. Nor do you need a rivet set to make a perfectly serviceable rivet. I fully expect that after riveting, these tongs will not open or close at all, but it is simple to fix that. Just bring it up to a nice even red heat and gently work them back and forth, and that'll adjust the parts of the tongs to fit each other. This jaw is a little bit long, so I'll go ahead and trim that off before we're completely done. This is a good time to refine those chisel cuts with a piece of square bar. I'm not sure what size square bar these will hold ultimately, so this is just a preliminary step. After I set them for a flat stock size, we can figure out what size they want to hold. For the flat stock size, I want these to fit 1/4 inch. You need to make tongs fit the material you want them to. They aren't universal. We'll do essentially that same procedure, but with a piece of 1/4 inch flat bar between the jaws. As our pair of tongs cools, I'm going to put a little bit of beeswax on these. Helps prevent rust, makes them look better, but mostly it kind of lubricates the joint so they work a little bit smoother. Probably still just a little bit hot. Now we had talked about left-handed tongs versus right-handed tongs. Well, those cool, we'll talk about what that means. As we rotate through, we're rotating towards our tong hand. That means that when we're all done, this rein, the one that's on top, the jaw is on the bottom, but the rein is on top, is towards the palm of your hand instead of your fingertips, so that when you have a relaxed grip, it wants to roll into your hand and not away from your hand. So you're less likely to drop the tongs. They're more comfortable, they're easier to maneuver. If you hold your tongs in your right hand, you still want to roll towards your tong hand, but you end up with a right-handed pair of tongs. Or maybe that's a pair of tongs for a left-handed smith that holds their hammer in their left hand. But as a right-handed smith, I hold my tongs in my left hand. So whether you consider this right-handed tongs for a right-handed person, or left-handed tongs because I'm holding them in my left hand, it doesn't really matter. As you make them, rotate the tongs towards your tong hand, and they'll come out right. Just hot enough to melt the wax, that's what I want. Then I can go part way down the reins where it's warm, but pretty quick it gets cool. You can certainly heat those up, but over time, the oil from your hand is probably going to provide plenty of protection for it. That's our completed pair of tongs, made the traditional way with a jaw forged from larger material and a rein from smaller material forge welded on, so you don't have to do all that big drawing out that most people do under a power hammer these days. I do want to thank Vevor for sponsoring today's video and for sending out those tongs for us to look at. Now, if you're not interested in buying your first set of tongs and you want to jump right into tong making, I get it. In the past, I've made a couple of videos on how to make tongs without tongs, and I'll link to one of those down here and the other one down here, so you can go look at those videos and see how you might be able to do this without having to have a pair of tongs to start with, or without having to know how to forge weld. In the meantime, I hope you have time in your day to get out to your shop, make something, stay safe, wear your safety glasses. We'll see you for the next video.